All right, we are in chapter 10, section 5. Let's warm up our brains a little bit and remember how these functions work. The average monthly precipitation in inches at a lake in California can be approximated by the function a sine, etc., plus 3. If the minimum precipitation is 0 and the maximum is 6, what is the value of a? That just means that we've gone like this, okay, where the minimum is 0, the maximum is 6. So a is going to be the middle, which is 3. What is the period of the function? If you remember, the period is equal to 2 pi over b, which in this case, b is pi over 6. So 2 pi divided by pi over 6. 2 pi times 6 over pi equals 12. That's the period. Here's our little review. Graphs of sine and cosine functions are called sinusoids. One method to write a sine or cosine function that models a sinusoid is to find the values of a, b, h, and k for these particular functions. Where a is the amplitude, 2 pi over b gives the period, where we see b in the equations right here. H is the horizontal shift, left and right, and k is the vertical shift, up and down. All right, so let's try an example. Write a function for the sinusoid shown below. What do we see here? First, we can find the maximum value and the minimum value from the graph. The maximum value and the minimum value, let's see if I can write that down. First, we find the maximum value and the minimum value from the graph. This is going to be on the y-axis. So we have the maximum value of 5 and the minimum value of -1. So the maximum value is 5, the minimum value is -1. This maximum and minimum will help us find our vertical shift. So the vertical shift is k. K is going to be the maximum plus the minimum. Let's write that. This is big M. This is little m. Maximum plus minimum divided by 2. So I have 5 plus -1 over 2, which is 2. So we know k equals 2. We can decide whether the graph should be modeled by sine or cosine. This is a matter of opinion, but for ours, because the graph crosses the midline on y equals 2 on the y-axis, the graph is a sine curve and it doesn't have any horizontal shift. Okay, what we see here is right there. So we found that k was 2. So I just drew a line at k equals 2 because that's our vertical shift. And it looks like our sinusoidal graph crosses our k line, the vertical shift, at the y-axis. So we aren't going to shift any left or right. Because the graph crosses the midline at midline y equals 2 on the y-axis, the graph is a sine curve, no horizontal shift. So I'm going to say h equals 0. Okay, finally amplitude and period. Here we have the period is 2 pi over b. If I look at, I'm going to go in green, 1 full revolution. So here, down and up to there, I can read my graph. My period is pi over 2. So I'm going to take this and solve it for b. There's lots of different ways you can solve this. I'm going to cross multiply. So I have 4 pi equals b pi. Divide both sides by pi. So b equals 4. Cool. So my amplitude is equal to maximum minus minimum over 2, 5 minus a negative 1 over 2, which is 6 over 2, which is 3. It's not a reflection. Regular sine curves start and go up, down like this, and that is what our curve is doing. So there's no reflections here. Therefore, a is going to remain greater than 0. So my function is y equals a sine bx, and then I'm doing a plus 2 because h is 0. That was fun. All right, modeling circular motion. At double Dutch competition, 2 people swing jump ropes as shown in the diagram below. The highest point of the middle of each rope is 75 inches above the ground. The lowest point is 3 inches. The rope makes 2 revolutions per second. Write a model for the height in inches of a rope as a function of time in seconds if the rope is at the lowest point when time equals 0. Whew. All right, let's talk through this. So that's our picture of what we're doing. 75 inches above the ground to 3 inches above the ground. So first we're going to find our maximum, which is big M, and our minimum, which is little m. At a rope's maximum, the height is 75 inches, and the minimum is 3 inches. Cool. We can use that to find our vertical shift, where k equals 75 plus 3 over 2. So that's 78 over 2, which is 39. Cool. Now we have to decide whether the height should be modeled by sine or cosine. So go back to the paragraph and read, when time equals 0, the height is at its minimum. That means if I had a graph at time equals 0, the height is at its minimum. I would say probably down there. So I think that would be a cosine function, okay, which is going to be, I believe, a reflection too. So our a value, our a value is going to most likely be negative. Reflection, can't spell. But we're not there yet, so let's pause on that. So I don't believe I have a horizontal shift. So truly h equals 0. Next, let's find the amplitude. I'm going to do maximum minus minimum over 2. 75 minus 3 over 2 is 72 over 2, which is 36. The graph is a reflection, so my amplitude is going to be negative 36 because I'm starting at the minimum. Okay? Going back to the paragraph, it says the rope is rotating at a rate of 2 revolutions per second. So 1 revolution would be completed. Let's do this. 1 revolution is completed in 0.5 seconds. So that's actually our period. So we can say 2 pi over b equals 1/2, because that's 0.5 seconds. I'm going to cross multiply, and I have b equals 4 pi. So let's write our answer. The height is what we're modeling here. I have negative a cosine b and our shift up. There we go. All right, let's write a function for this. Looks like my maximum is 2. My minimum is negative 2. So I'm going to say my k is going to be 0 because I add those together. I get 0 divided by 2 is 0. What's the next thing that we need to do? Are we sine or cosine? Well, if this is my middle and I start up here, I'm definitely a cosine function. So we go from here to there. It looks like that is my period. So period is 2 pi over 3. To calculate my period, it's 2 pi over b. Let me restate that. I'm going to erase this really quick. We know to calculate the period for a cosine function, it's 2 pi over b. I know my period in this case is 2 pi over 3 because that's 1 revolution of my cosine function. So let's solve for b because I need b for my equation. 6 pi equals 2 pi b. B equals 3, which we could have seen right there. Okay, so we have b, we have k. Because my function starts up here at the top, at the maximum on my y-axis, I know that I'm a cosine function with no vertical shift, or no horizontal shift, sorry. So h does in fact equal 0. My amplitude is going to be minimum or maximum minus minimum over 2. 4 over 2 is in fact 2. I think I've got everything I need. It opens, or it's not reflected. Let's go ahead and write our answer. Y equals a cosine b x. H and k are both 0, so I'm done. Try again. Let's see. My maximum is 1. My minimum is negative 3. My vertical shift is then 1 plus a negative 3 over 2. 1 plus negative 3 is negative 2 over 2 is negative 1. What else do I know? It looks like if I draw that line, right there is where I start, so my horizontal shift is 0. If I start here and I go to there, it looks like my period is 2, so period is calculated by 2 pi over b, and in this case it's 2. So let's go ahead and solve for b. 2 pi equals 2b. Divide both sides by 2. B is pi. My amplitude is minimum minus maximum, maximum minus minimum over 2. So that's 4 over 2 is 2. And it's not reflected, so my A stays positive, and I believe I have my answer. Y equals 2 sine bx. Oh, I forgot that part right there. Sorry. So minus 1. Sorry about that. Cool. All right, what if? Describe how the model in example 2 would change if the lowest point of a rope is 5 inches above the ground and the highest point is 70 inches above the ground. So that means our amplitude would change to 70 minus 5 over 2, which is 32.5. And then our vertical shift is k, would be 70 plus 5 over 2, which is 37.5. Okay, that's all that changes there. All right, moving on. Sinusoidal regression. Another way to model sinusoids is to use a graphing calculator that has a sinusoidal regression feature. The advantage of this method is that it uses all of the data points to find the model. So the table below shows the number of kilowatt hours, K, in thousands used each month for a given year by a hangar at the Cape Canaveral Air Station in Florida. The time T is measured in months, with T equals 1 representing January. So that's January. Write a trigonometric model that gives K as a function of T. So I'm going to push the stat button on my calculator. Hold on, I'll show it to you. It's right here. So press that button and then select edit. And then fill in all of your information. List 1 is going to be your years, 1, 2, etc. List 2 is going to be the data. Goodness, what is it? Go back to the slide. So this is going to be my K values. This is going to be my T values. Okay, so go ahead and fill those in, and I'm going to work on this. So give me a second. I'm pushing pause. And that's where we are. Okay. Hold on. Next slide. All right, the next thing we're going to do is construct a scatter plot. So we need to hit the second and stat plot buttons, and we'll get this screen. I need to make sure my plot 1 is highlighted. It's on. This is the graph that I want. I typed all of my information into list 1 and list 2, so that's what I need to have there. This is list 1 and list 2. Didn't mean to cover over that. And then I want everything in a small dot. So once everything's there, I press enter, or I press graph, sorry. I forgot to tell you, you're going to want to hit zoom button right here and select, let's see, it's number 9 says zoom stat. And we get a scatter plot. Let me show it to you. Pretty cool, that's our scatter plot. Now we're going to do a sinusoidal regression. Okay, let me show you how to do that. Let me write it down. We're doing a sinusoidal regression using all the data we have. So what I selected here is I hit the stat button again, and I went over here and highlighted calc. And here is the sinusoidal regression. So select that, hit enter. So after I hit enter, this is where I am right now. Iterations 3. This is where I put the data in list 1 and list 2. I don't know the period. I do want to store my equation. So my regression equation, I'm going to store in Y1. I had to select that. Down here, you're going to see a vars button. So go ahead and hit that vars button, and then you're going to want to select Y vars. Number 1, which is the function, and Y1. That means it's going to store my equation in Y1, which I want to happen. Sorry, I'm doing that right now. There we go. And go ahead and hit enter, and it's going to calculate it. And spit out an equation, which let me take a picture to make sure your equation equals my equation. So there's the equation. If you look at it, this is the form the equation's going to use. So I've got my amplitude, my b, this is plus c, but we don't use those. We use h and k, but that's okay. And these are the variables that go into this form. Cool? Now, I stored that equation in y1, so I'm gonna, actually I can hit graph and it'll graph it for me, but let me show you. So I hit the graph button. I still had my scatter plots turned on, so you'll see the dots are still there, like there's a random one, but it did the sinusoidal graph over it, and it's perfect. So I graphed the model. So my answer, if you look at that last slide, it's a really good fit. It looks really good. So I can have k equals 23.9, which is the A, sine 0.533t minus 2.69 plus 82.404. Okay, so that's your function. Pretty cool. Use a graphing calculator to write a sine model that gives the average daily temperature, yada, yada, yada. These values are going to stay the same, but I'm going to go ahead and change my list 2 for those values. I hit stat, edit, list 2. I can clear everything in that list and type the values in. So I had to rezoom my window. I did everything in the last that I did in the last few slides. If you're not sure of the steps, go ahead and review them. Go ahead and calculate that again because I lost my page. Sorry, here we go. So my formula, my function is k equals 21.8, sine b is 0.514, x plus, that's actually a minus, 2.18 plus 51.3. Pretty cool. It appears to be a really good fit too. All right. The highest point in the rotation of a robotic arm is 30 inches above the ground, and the lowest point is 12 inches above the ground. The arm makes a half a revolution per second. Write a model for the height h in inches of the arm as a function of time if the arm is at its lowest point when t equals 0. So let's see. Our maximum is 30 inches above the ground. Our minimum is 12 inches above the ground. So our k value is going to be 30 plus 12 over 2. That's 42, so 21. I can do our amplitude because it uses the same values. I have 30 minus 12 over 2. It's going to be 18 over 2, which is 9. It says that my lowest, time equals 0. I'm at the lowest point, so that's a negative cosine function, so negative 9. My h value, I'm not shifting left and right any, so my h value is going to in fact be 0. So I still need the period. The arm makes a half a revolution per second. So 1/2 a revolution per second. That means I would have 1 revolution in 2 seconds. So my period is 2 pi over b equals 2 seconds. Cross multiply, 2 pi equals 2b, b equals pi. So my equation is going to be h equals -9 cosine pi t plus 21. Okay, I'm not going to go through the math again, but if you want another one to check your work with, here is the answer. Okay, this is the regression. Cool, well done.